Today, we're diving into something pretty incredible, a new frontier in mental health. We're talking about an AI that's learning to detect depression not from the words we choose to say, but from the thousands of tiny involuntary clues our bodies are giving away all the time.
I mean, just think about that for a second. We choose our words carefully, right? We filter them. But what about the flicker of our eyes? Or a subtle shift in the tone of our voice? Or facial expression that's gone in a flash? These are the kinds of objective signals, things we don't even know we're doing, that researchers are now teaching AI to read. And look, the need for new tools here it's massive. Depression isn't a niche issue, it's a global health challenge that affects roughly 1 in every 20 adults. That means millions of lives, millions of families are touched by this.
So that really begs the question, right? For something so common, how do we even diagnose a condition that lives inside someone's mind? It's incredibly complex, and our current methods, well, they're essential, but they definitely have their challenges.
Okay, so let's start right there with the diagnostic dilemma. Before we can really get why this new AI is such a big deal, we need to understand the way things are now and exactly why researchers are pushing so hard for a new approach.
So right now, diagnosis pretty much stands on two legs. On one hand, you have clinical interviews, where a doctor uses their expertise to interpret what a patient is telling them. On the other, you've got self-report questionnaires, which completely depend on a person's ability to be honest and aware of their own feelings. Now, both of these are absolutely fundamental, but you see the shared problem, right? They are both, by their very nature, subjective.
And that subjectivity, that dilemma, is exactly what pushed researchers to ask this really powerful question. What if we could find objective clues to add to the picture? And that brings us to our next section, how scientists are looking beyond words to find data in our involuntary behaviors. And this is where it gets really cool. This slide shows you the tri-modal approach at the heart of it all. It focuses on 3 key signals that we just can't fake. First, eye tracking, which can see if our attention is subconsciously getting stuck on negative things. Second, facial analysis, which can spot something called affective flattening, basically a smaller range of emotional expression. And third, audio analysis, which can pick up on changes in our speech patterns, like talking slower or with less variation in pitch. So you might be thinking, how on earth can an AI analyze all of this at the same time? Well, that's where the real innovation kicks in. It's not just about what the AI is looking at. It's about how it's been designed to listen on, well, multiple frequencies. The whole thing is built on something called a graph convolutional network, or GCN. Now, don't let the name scare you. The easiest way to think about it is that a GCN is an AI that's an expert in relationships. It doesn't just see a sad face and slow speech as 2 separate things. It's built to figure out how they connect and influence each other.
Okay, now this is the secret sauce. The data is broken down into frequencies. You've got your low frequency info. That's the big picture stuff, the obvious things. But then you have the high frequency information. And that's where the hidden clues live, the micro expressions that last for a fraction of a second, the tiny tremors in your voice. Most older AI models, they only looked at the low frequency stuff.
And that's the breakthrough. This new model, the MF-GCN, uses what's called a multi-frequency filter bank. It is designed from the ground up to listen to both the obvious low-frequency signals and all those hidden high-frequency details. It's not choosing one or the other, it's getting the whole story, which gives it a much, much richer picture of what's going on.
So it sounds great in theory, but does it actually work any better? I mean, that's the million-dollar question, right? Well, the researchers put it to the test, and honestly, the results are pretty stunning. Let's have a look. Okay, let's break down this chart. We're looking at something called the F2 score. It's just a way to measure performance, but it has a really important twist. It cares more about correctly identifying people who do have depression. In a clinical setting, that's what you want, right? You don't want to miss anyone. And as you can see, the new MF-GCN model on the right clearly comes out on top. And to put that performance into a really clear number, the model hit a sensitivity of 96%. What that means is, when it was asked to tell the difference between people with and without depression, it correctly spotted the ones with depression 96% of the time. That is an incredibly high level of accuracy.
And just to show you this wasn't some kind of fluke, check out this head-to-head comparison. They put it up against other well-known models, from the classic to the cutting edge, and the MF-GCN just consistently performed better. It's not even close.
But here's the part that, for me, really proves this is legit. The researchers didn't stop there. They took their model and tested it on a completely different set of data from a different study. and it still performed incredibly well. That proves the model isn't just a one-trick pony. It shows its abilities are generalizable.
So, what does this all mean for the future? For real doctors and their patients? That takes us to our final, and I think most important section, where we look at the real-world potential of all this. Now, I want to be crystal clear here. The goal is not to build a robot doctor. The real potential is to create a powerful new kind of tool. A tool that could help reduce that subjectivity we talked about, help spot symptoms earlier, and just give doctors objective data to go along with their own expertise. It could mean faster screening, a more complete view of the patient's health, and maybe even more personalized treatments down the line. And this quote from the research community really says it all. The key word here is support. This is all about augmentation, not automation. It's about empowering human experts with better data so they can make even better decisions.
So, we'll leave you with that question. As technology like this keeps getting better, it really makes you wonder. By finally learning to listen to the stories our bodies tell, maybe, just maybe, we're on the edge of unlocking a new era in mental health. One that's more objective, more accessible, and ultimately more effective for everyone.